Good day, ladies and gentlemen. I'm Sauradeep, your host for today's webinar. Thank you for standing by and welcome to the Esri India webinar on digital transition to digital transformation, a utilities perspective. This is the third of the 3 webinars planned in Future Utilities webinar series. The key objective is to share how new platform-based GIS enables digital transformation. The speaker for today's webinar are Dr. Pradeep N. and Ms. Mithika Garg. Dr. Pradeep N. is the Industry Head, Utilities, Transport and Mining at Esri India. He has nearly 18 years of experience in industries as well as research in the field of GIS technology application and consulting. Dr. Pradeep has a PhD in GIS and RS applications. Mithika Garg is pre-sales consultant at Esri India. She had an industry experience of 9 years in GIS domain with major focus on utility industries. She is Schneider Arc FM certified expert and is involved with mega projects like R, APDRP, and companies like HCL, TCS, Sterlite Grid, and Cons Energy. For the duration of presentation, all participants' line will be in listen-only mode. We'll also have a panel of Esri India experts on call to answer any queries you may have. We will have a Q&A session post the presentation, so meanwhile, if you have any questions, you may also send them across to all panelists using the chat window on the right-hand side of your console. So now, without any further delay, I would like to hand over the proceedings to Dr. Pradeep N. from Esri India. Thank you, and over to you, sir.
Thanks, Shubhadeep, and good morning to all the participants, and thank you for joining us. In the next 60 minutes, we'll try to present the perspectives that we have seen and understood in terms of how we can enable a digital transformation within the approach and leveraging the various digital technologies that are being developed, implemented, and utilized across the IT landscape. And also look at how we can build upon the existing digital transitions that we have made or the utilities have made over a period of time. And what is the core basic difference when we talk about a transition and transformation, and how GIS and location intelligence plays a very vital role in this transformation. So as Shubhadeep said, this is the third of the webinar series. Earlier we have covered how GIS-based asset management system can bring value to utilities. Then we have talked about how we can increase the operational IQ of the systems and the organizations to enable the processes. And at the same time, we also looked at how we can leverage big data sets to bring in more operational intelligence when juxtaposed with the IoT and sensor devices. So today we'll look at how all these changes in the landscapes can enable a lot of transformational abilities within a utility to take the business processes forward. So when we talk about digital transformation, it becomes imperative to understand the overall landscape and what do we actually mean by transformation and what we have achieved so far. Over the years, utilities have digitized a lot of their processes, a lot of their data, a lot of their business entities, but these are still more of a standalone business-specific systems. Maybe it's a billing and revenue system, maybe it's an ERP system, or it can also be systems like the OSS systems like SCADA. But each of them are doing their own bit, providing information and intelligence for their realm of work. But this is only a transition from an earlier method of working, earlier process of capturing information, and generating a digital twin of what are the assets and the processes. The transformation occurs when we can enable these information to speak to each other, these information to influence each other in a way that the executive or the managers or the decision makers have information available for a decision support system. And this transformation can be enabled when we have a platform. So when we talk about a platform, GIS is becoming a platform because it provides capabilities not just to host the digital data, the network information of an utility, but it also provides the vital locational information and also the integration interfaces that are required for collaboration and information sharing. So, in a nutshell, to move from a transition to a transformation, what is required is a platform-based approach, have a central platform, and enable the data exchange and collaboration at a platform level. So for this, now location itself is becoming a platform. Location is critical because for any of the assets, any of the events, any of the incidences, location gives a context. Where an incident is happening, why it is happening, are there any environmental influences occurring or triggering such events, what are the associated entities or assets that are getting affected, if there is an outage, what is the cause of an outage, what are the affected customers for that, and who is the nearest field crew that can attend to that outage. Hence, location in a digital transformation scenario becomes very critical and it becomes an integral part of the overall locational intelligence and overall IT enabling systems. So when we look at transformation, we need to look at the three basic drivers of transformation, which is communication, coordination, and collaboration. Communication, not just of a physical nature, but communication between devices, communication between systems, and communication between entities which can impact each other. Now, coordination between the field staff, coordination between the decision makers, and coordination between the managers. So this is what gives rise to what is the system of engagement, wherein multiple users and multiple entities engage with each other, share data, communicate, and these two gives rise to what is called as the collaboration. So free flow of information, ideas, and situational systems enables a collaborative environment which together would drive a digital transformation. So to put transformation or a digital transformation in a nutshell, it is transforming not just the way the systems are looked at, but also to change the basic business activities, the processes, and also building internal competencies to address these digital age challenges and requirements. So to look at the digital transformation, McKinsey has put out this four basic key factors of to look at an organizational's digital quotient, which includes strategy. What is the strategy the organization has? Do we have the organization has it built a strategy? If that strategy is there, what is that they are trying to achieve? What are the cultural changes that we are looking at, whether it would be business as usual, just copy a existing business process and have a digitization of the process rather than looking at actual changes in the way that business is done. Then the structure. What is the internal structural and processes changes that need to be brought in once those cultural changes are put in place, are intended to do, and we have a clear-cut strategy to achieve the goals. These three components need to be supported by internal capabilities. What are the internal capabilities? For a long-term sustainability, building competencies within the organization becomes critical across the digital transformation workflows. So the 5 key components that would be driving this digital transformation to utilize the existing data flows within the organization to get an insight and get this insight to power the decision support systems so that appropriate actions can be taken. The 5 components that would drive the digital transformation would be, first of all, to have the digital twin of the various systems that we have for the utility. Leverage the computing power of the cloud. When we say cloud, it can be a private cloud, a public cloud, or the various web-enabled systems that are now able to transmit data in a ubiquitous manner, wherein any of the other systems, open systems, can fetch, utilize, and inquire and process that information. Once this data flow is done, once the collaboration is enabled, the next step is to have tools for advanced analytics, the locational analytics, the big data analytics systems, and then enable communication systems through multiple mobile data systems, which can be a simple mobile app, it can be devices, it can be the IoT systems, which can give out information from multiple locations. And when all the structural processes and structural systems are there, that would definitely give rise to a overall organizational collaborative environment wherein this data exchange is not just limited within the organization, but it can be shared with the required stakeholders. So utilities always have this problem of, especially when we look at the road digging systems. The municipalities have their own plan, the utilities have their own plan. If they are able to collaborate and have a common picture, definitely they would know where the utilities would need to seek permission from the digging, and the municipalities would know what is their plan for any of the road maintenance. So this kind of a collaboration and a collaborative environment can be set up in terms of to look at the digitally transforming our processes. So to put these systems together, we can now start looking at the overall digital transformation in 3 different phases or stages. 1, to digitize all the systems and have a data collection environment set up, what we can loosely term as the system of records. So all the data starts flowing in, the backend databases are set up, the processes are set up. Now once the data starts to come in, this data can be shared across multiple applications to multiple stakeholders as per their requirement, and enable the users to start sharing their data, sharing their inputs, and carry out their business processes through the system of engagement. Now, when we have the data, centralized data flow, and when we have the users connected, there is a lot of information that is generated, which, when enabled through analytical systems, would give the required insights as to what the systems are going through, what is the relevant information, how the assets are performing, and this system of insights would enable a decision support. So basic 3 stages of transformation is to enable systems for data collection, enable systems for user or a stakeholder engagement, and enable tools to analyze, process, and receive or to build intelligence out of the data that is collected. So we saw as the first step, or even when we looked at the first webinar where we used the GIS for asset management, the first step, or even for increasing the operational IQ of an organization, the first thing to do is to digitize assets. So the digital transformation starts with digitizing the assets, bringing them into the digital domain, have a digital twin of all the records, and once the asset digitization process are done, enable this with the users. The way people want to use it, the way people want to see the data, and for the applications for which they want to use. So digitize the data and enable it at multiple levels, at multiple component access to multiple stakeholders. Once we collect this data, now enable that for the field. When there is a flow of information and collaboration between the backend and the field force, there is a lot of information exchange that can happen, and workflows and apps can be enabled which can summarize a lot of this transformational processes. When we have all the systems, the centralized data, and have the platform in between, the same data now can be integrated with the IT devices as well as the operational systems and provided through a common identifiable interface for multiple field users. Users who would be doing a simple transmission survey, or a person who would be doing in-depth analysis for reporting, or somebody who would be looking for any kind of a locational intelligence to carry out the ground and the civil work or the contractual works. So the entire system now for multiple users can be brought in as part of the digital transformation, and this leads currently to the advanced analytical and visualization processes. We know with a lot of IT and OT devices being put in utilities, most of the utilities are becoming data rich. Now, this richness of the data need to be harvested, because now again we are having most of them as silo systems. Now, but when we link it to a locational intelligence, this would enable a lot of exploratory systems. What is happening? Why is it happening? Where is it happening? And also link it to multiple processes that can be linked as to how the entire process can be relooked when we are doing. Maybe it is a simple data update from the field. Do we really need to go in for an extensive DGPS-based survey, or is it possible that once the main structure is there, can we start do an incremental data with a simple mobile device? So these kind of analytics starts and visualization starts to flow in once we have the system and the data flow established. And then the insights. Do a deep down information, bring in the large database, the big data systems, whether it is we have the data in SAP HANA kind of a systems or any kind of a big data, wherein near real-time data, the census data can be fetched and analyzed in a near real-time basis to get larger insights as to the performance of the assets. So ultimately, digital transformation, if you look at it, the approach needs to change. From thinking about how do we fit GIS to the processes that the organization follow, to how do we re-engineer the processes wherein the strength of the locational intelligence can be harvested better, and GIS enabling it would become a focus area rather than the processes and business requirements becoming the focus area. So a transformation would require, as summarized in the earlier slides, a change in not just the intent, but also the very culture of doing business, and to put in places the processes, the reworked workflows which would leverage on the strength of locational intelligence to support the business. So with this, I'll hand over to my colleague Nitika to take us through some of the demos, which shows how we can look into transforming the various data collection and the processes of transforming the system of insights and the system of records. Nitika, please.
Thanks, Pradeep. Thanks, Pradeep. So as Pradeep has said, for any of the utilities, we need 3 C's is very important. Like every utility is having a different kinds of systems, like outage management systems, advanced metering systems, work order management system. But these systems need to collaborate in between, communicate and coordinate with each other to bring insight and analytics, to do the analytics on this and bring us some insights, information, and then they can work. So being integration is very important in between these systems. So how we can integrate and coordinate between these systems. So we are going to cover few of the demos from like how a field worker can integrate the information to the centralized server and how they can get the easy update, which will help in increase in ROI in terms of cost and time also. So first demo will be covering about the as-built mapping. So generally in each of the utility, I'm not talking about any specific utility, we have come up with the mapping or the project construction status, because utility field staff will also need to know about what is the status going on the field, how much construction has been done or any field mapping has been pending. So how we can enable that? So using the desktop-based tools, we can map what are the already existing status of our assets are there, and then enabling that into a structural data model, we can organize them, and then we can put that in a collaborating manner in a web-based system where we can enable our field crew locations also, where they can update the project status. Also, if any new sites is being going to construct, so they can update the as-built drawings, and any reconstruction site is also going to happen, so they can update the status. So how you can see in the left-hand side, the legends are there, like which are the project locations which are the active, how is the status is going on from active to in progress to complete, and how they are changing their locations also. So how we have enabled the network as well as the field crew information and the updates which is coming from the field apps through the systems, and then enabling that into a dashboard which will give a view where you can see like these are the locations where the projects are in construction state and where the projects are in mapping state. So you can see that these are some different colors of points which you are seeing on the map, like red color. So it is showing like this is construction is completed. So it is giving the complete information when it is started, what is the creation date, and then you can also get the information like who all are the contractors associated with that. So you can see that the information is coming from the different systems and getting collaborated in a single dashboard where you can get the GIS information also, and also the construction status also, and the contractor information also. So here you can see what is the completion status. So they can get the instead of like it will save the time also, and in terms of cost also, the person in the field at a time he can update the project status. So the person in the office will get the real picture of the work which is going on the field. And also this kind, like these are the different projects which are where the mapping status is going on. So how the basic objective was to show how field worker and the mobile apps and using the enterprise platform, you can sync and collaborate and coordinate between from the field place to the office place and to the enterprise system and get the insights what's happening in the field. Now we are going to just another demo. Same we can replicate using for the telecom systems also. Let's say we have a telecom sites also. So there and some of the applications are like configurable applications of the mobile apps, like for the collector for ArcGIS and Survey 123. So we can design a different kinds of forms where we can have a site inspection attachment also. So here we can also enable the field crew team locations also. So we can design these kinds of forms where we can update the status of the site information, what is the site material is getting used, and the owner, and all the information along with the photo, signature and all. And then the updates can get into a kind of dashboards where you can see these green color locations are your workers and who all the workers are the working, and these are the site status where sites have been divided into different grids. And it is the multi-site inspection. You can see where the which worker is there and who has completed their status and what are the assigned. So this single picture will give you a complete insight, like what is the status going on the site, different sites, what kind of material is getting used, whether it is for the electric utility or the telecom utility, because sometimes there's cables going underground both for the electric and the fiber cables also. So you can have a complete picture in a single enterprise dashboard where you get the feel of the real system. So this is how field crew can enable and integrate the systems. Now we are going to cover one of the another aspect for the transmission as well as the utilities basically. So generally utilities also spends a lot of time and money also for inspection of their towers, because they need to monitor their towers, because if there's any fault happens, so it will take a lot of time to recover it and get it into a good condition. So generally inspections can be happen through the air patrolling or through the by ground-based visual surveys. But due to lots of technologies like configurable applications like collector for ArcGIS, drone to map, dashboards and workforce. So being collaboration of all these apps, you can have a output which will help in saving the time also and lowering the cost also, and which can enhance the safety also. So how we can do that? So by integrating your data into a dashboard kind of system where you can get a detail of your tower, like where the drone has captured that and what is the status of that asset. Whether by seeing the picture they can inspect the asset, like if any problem is happening there, and then management can monitor the progress of also the inspection. Then if any issue is found in there, they can enable their field cream also. So how this is being possible? So we have a drone to map software which basically takes input of the drone images and which converts that into a different kinds of output. So it's not a single output, it has a point cloud data also, it has a DSM also, ortho mosaic images also, which can be further used for doing the lots of operation and analytics on top of that. So like if you have captured the images from the drone, then by using the inspector, they can inspect the images, like any fault happened or any tampering has been happened over there, and then they can dispatch their field team there by using the different kinds of mobile workforce and applications. So they can send their field workforce by using the collector for ArcGIS or workforce for ArcGIS, and then they can process that images. So this is for the tower inspection. So once you process that images, so you can have lots of images are there in the system. So we have different kinds of extensions are there, and server is there to manage that images into a centralized platform. So instead of putting that images into some hard disk and storage that into some place, we can assemble that in a structured manner in a enterprise environment, where we can search any time of any kind of image which is captured through the drone and process. So further utilities inspecting the towers also have a major basically they monitor for the ROW maintenance also. So ROW maintenance is also a costly and the time-taking affair. So by enabling the GIS integration there, how we can like generally utilities like inspect their ROW by walking the ROW or by the aerial patrolling. So by enabling the drone to map interface, they can click the photographs of that area and they can process that corridor and they can produce the output related to that, and which will give them the complete inspection of that area. And that further using the drone to map, you can see these images are being captured and they will give the path how the drone has been flown. So this is the path how drone has captured the images, and then further they have processed that images and using the inspect tool they can visualize where their locations of the towers are there, and then they can provide the output in terms of orthomosaic and the cloud. And further using the tools, different processing tools and all, they can inspect the areas which are near to conductors basically. If any vegetation is near to conductor, they can visualize that also. So like this is in one of the ROW, you can see these lines, and this is the vegetation. So using the different analytical tools, we can identify like this is our area which we have classified into a certain vegetation, and the red color areas are the more prone areas which are near to vegetation. Then the output which is coming through the drone, we can have a point cloud data also, which is the LiDAR point cloud, and we can see through this into a 3D scene where we can see which of the vegetation is nearing the conductor. So we can send our field team to get it like processed or get it rectified in the field by the field workers. So we identified that this is area which is coming near to conductor. So these are so the main objective of showcasing is this, because it is giving you a complete picture where we have enabled the drone processing, enable our field workforce to get it rectified, and by using the desktop based tools and various analytical tools doing modeling and all, we have come to know that these are the areas which are need to be looked out by the field team to repair. So we, instead of like it helps in the saving time also and ensuring the safety also. So this is the one of the example for the inspection. Now we'll be going to another demo that will be the insights for ArcGIS. So as Pradeep has discussed that we have a lot of analytical tools which will help in analyzing the condition of the assets and what's going in the field and what's going in the assets performance. So this is our demo which basically giving you an insight like how the outages of the taking place and what are the like major reasons outages are taking place, like what are the devices which are involved in the outages and how much is the outages is happening and what are the monetary losses which are happening place, and the objective is which are the major devices which are causing that. So by just enabling an integration using XLS-based records or different systems, like it can be integrated with the GIS system also, and you can integrate with the other CRM systems and SAP HANA systems, and you can put that into a different kinds of pictures. So you can see in the first card, this is showing you a heat map where the distribution of the devices which are causing the outages has been taking place. And then in the this side you can see in the left hand side, the attribute informations are there. So it is basically showcasing you how outage is basically taking place. So there are different parameters are there, like outage count and what is the total outage time and what are the total monetary losses. So I have drawn in the second card what is the total outage count. So if I select any of the card, it will show me this outage count is 170. So you can see all cards are synced to each other. So the outage count is 170 is possible is happening through the switch devices. So in the third card you can see the switch is highlighted in this. So the major reasons of the outage is switch. But when I see the outage time, so outage time is here. And if I see the customer affected, so the count is a little less, only 5 customers are affected. So through this kind of analysis, we can come to know, like if we see the outage time analysis. So if we select, so we can see the outage time where it is more possible, it is 60 minutes outage is there, but the device which is responsible for this kind of outage is the transformer. And you can see the outage device ID which is causing the outage for this, it is this ID which is a unique ID for industry as systems, and it is causing 15 customers affected. And if you see the outage count, outage count is also 5. So how with the single XLS we have come to know, like this is the device ID which is causing the outage time. So how this is possible? So we have one of the blank space, how we generally do it. So we can add the data coming from the different sources, like we can add from the databases also, and we can add directly if we have some XLS information also. So we can add from the different sources. Once adding the data, it will enable us to do the analytics on top of that. So once it is added, it will show me the coordinate locations. Just a minute. So once it is added, it will show me the coordinate locations, and I can put that coordinate and I can generate a map. So it will automatically distribute and locate the locations of the coordinates where it is locating. And then further we can generate a hotspot map or a heat map which will tell me which is the place where the major outages are happening. So this is the way where we can create a one card. And now we have other devices also, like we have a device ID, device type. So which are the device types are there? So we can have various kinds of charts where we can see the transformer. So these cards are linked to each other. So the way of creating the analytics in the insights is we can use the several parameters, and we can come with the analytics like this, which will tell me like these are the possible devices and these are the transformers are the causing the outages at which location. So these cards are auto linked to each other, and then if any organization was doing this kinds of analytics, they can share this analytics using the share button, and it will map the complete model like this. And so this can be shareable to anyone in the organization. So this is and it can also be you can also change the new additions also, and you can also integrate the data coming from the other systems also. So this is the insights picture. Now I'll be showcasing the another demonstration, which is basically integrating a GIS system and the billing system. So the insight of showcasing this system is how you can integrate a system and coordinate and communicate between the two systems, where in GIS information is coming where the feeders are, the location, where the meters and others are installed. So you can see in the left hand side we have a legend which is showcasing different kinds of attributes are there, like electric station, billing. So this is one of the electrical utility data where you can see these blue colors are the feeder lines, and these are the distribution of the customers, like these are some agriculture customers or commercial customers, domestic customers. So we have distributed that, and then it is also distributed feeder wise, like at a one feeder, how many customers are there. So, and if you see in the right hand side, this is the billing information which is coming from the CRM system, and we have integrated that system. So if somebody would like to see information of certain feeders, so we have a filter there, and it will, all the statistics will change according to that filter. So this is the one feeder where you can see around count is customer is 1,000, and you can see how the phase-wise distribution of customers are there. And on the right hand, I can see what is the sanctioned load there and connected load. So through this, you can also see the consumption status, how much consumption is happening in the last month and the last 5 months, what is the consumption happening, and what is the total sanctioned load on that feeder. Then we can also see same with the feeder with the DT-wise also. When we have done the filter, the DT-wise, we can see that these are only the customers which are in the yellow color. So when we have seen the legend, these are the commercial customers. So this insights we are coming and getting from this, which are that commercial customers are having a total sanction load of 14.90. So how we have integrated the distribution of the GIS system and the CRM system into a single system. So this is giving us insight that these commercial customers are located here, and what is the total consumption status of only the commercial customers. So the main objective of giving a picture of this dashboard is it's giving an insight where we can have 2 or 3 systems which can integrate, collaborate, and communicate and provide a feel of what insights is happening, and then we can come to a picture like we need to work, or the utility needs to work on this sector and to improve in terms of enhanced safety and also saving the time and the cost also. So these are the demos for today. Now I will hand over to Dr. Pradeep for the question and answer session.
Thanks, Pradeep. Thanks, Nitika. So we have a few questions which have come in to us. Let me quickly read them out. There's one question from Ranjit. He says that GIS is considered as a single platform for asset information. What will be the role of enterprise asset management softwares which are typically used in utilities such as Maximo, Infor, ABB, Ellipse, etc. So, Pradeep, do you want to take that?
Yeah, sure. Thanks for the question. It's a very interesting question. See, when we talk about an enterprise asset management systems like IBM Maximo, definitely they will help in managing the assets and asset-related information, and probably the entire asset lifecycle information too. But what GIS provides would be the crucial element of the locational intelligence. So if I take IBM Maximo also has the GIS integrated flavor as IBM Maximo Spatial. So what GIS does is to first enable assets, link it with their asset database, and for managing the asset related information in terms of the procurement, the contractor, the maintenance schedules, yes, there's still the traditional asset management systems still play a critical role in it, but what GIS would do is to put this onto a map, and then when we look at a maintenance schedule, it will give for a given area what are the systems, what are the entities that would need maintenance with a particular period. It will also help the asset managers to plan on a schedule wherein they can identify if there is a problem with a particular model or a make or a manufacturer provided system. They can look at which are the other similar devices that are there, how they are spread out, and whether certain similar reports or similar incidences have been reported on those entities too. So if it is a recurring problem, then we can look at the secondary aspects of what are those effects. But then having GIS enabled to it would definitely help in better coordination, better maintenance schedules, and deriving a much different management plans wherein they can optimize the field crew, optimize the field resources for managing the assets better.
So I think, Pradeep, there's one more aspect to this particular question which I feel, because it is because asset management is one of the core process of utilities.
Yep.
So while that is important, but there are other processes also. And what GIS system you talked about, that GIS is actually becoming, there are three pillars of the digital transformation. One is system of records, and this is which is where the asset management lies.
Right.
And then we also have system of engagement and system of insights. And actually GIS actually provides a platform that it will integrate all other systems and providing a common platform. I think that's also a very important aspect that will come into play for any enterprise. I hope that that answers your question. Ranjit. We have, I think there's another question which is coming from Arun, who says that, while you talked about, system of collaboration, right? So, I think what I understand is the primary concern is around the data security or the control of the data.
Yeah.
So, you want to talk a little bit about that?
Yeah, see, now in terms of data security, most of these systems, they all do have their basic certifications, IT certifications and all those things in place. At the same time, if I need to talk about from the Esri RGS platform, all the data can get into an encrypted format, point to point. We can have the SSL encryption done. And at the same time, this security can be done or put the user access at multiple levels, right from the application level to the data level to data layer level. So all those components would come in terms of securing the data. And when we look at the collaboration, we are generally collaborating at the web services level. So this web services level, when we talk about, so these can be REST services or SOAP services or any of the OGC compliant services that are there. So we are not actually exposing any core data to the end users, but it was more of the web services level integration that is happening, which would definitely have the security built into it. And the concept of the centralized system of record and having the capabilities of having the web-based enablement itself is the core driving it, because all the data are stored behind the organizational firewalls. So you have the user authentication command. This user authentication can be a single-step authentication, multi-step authentication that the organization wants to follow. And at the same time, we can have the user group-based or the user level-based access defined, which would further enhance the data security and data exchange protocols that we want to set in.
So I think while data security is one aspect, but I think one of the key benefits of this platform is that it gives you control in terms of what is it that you want to share and what you don't want to share.
Yep.
So you can decide that these are the set of people who want to see who will have access to only this information. So I think that control will always be there with the user.
Yes.
So they can decide that what is public, what is private, what is semi-private. So those functionalities are available by
Sure. And the second, the other aspect is that though we talked about cloud enablement of the systems, this can be a private cloud that we are looking at, or the public cloud. The component that happens is that there is no data exchange that is getting into any third-party platforms. Whatever is being generated, whatever is being stored is within the defined boundaries of the data integration scenarios.
Okay. Thanks, Pradeep. I have another question again from Ranjit, who says, how can a drone capture image be utilized and integrated with GIS or ArcGIS? I think to some extent we actually covered it. Mithika, you also showed a demo of it. So if you want to add a little bit more to that?
Sure. So when we talk about drone integration, Mithika has already shown how it can be utilized for a transmission line survey. So we can extend this to, say, for example, we have the long distance oil pipelines. So when we have the long distance oil pipelines and satisfying all the regulatory requirements, if we can capture the proposed ROW or the existing pipelines, the drone captures can be done at multiple ways. One is the simple captures that would give images that can be georeference tagged, visualized, or this can also have the LiDAR, the last component, wherein we can start analyzing the point cloud and start building the 3D capabilities also. When we look at the drone captures, it is faster. Otherwise, it would have been much more, or currently we have the line walkers who go all the way, whether on vehicle where it is not on foot. One is time consuming. Second is the repeatability is, the cycles are much longer. But if we can have segments where we do a drone capture, if there are something like in a pipeline there is a leak, definitely that can be captured much quicker, and the field staff can be prioritized to address those leaks rather than depending on the field walkers, their feedback coming into play. So similarly, within the other one, it may not be related to just utilities, but if we are looking in terms of the transportation network, the road condition management and all those things. So drone captures, and especially if we can have the full motion videos, now we can relay these videos corresponding to geographic location and start capturing the information from the videos itself.
Okay. So I think there's just one more question which probably I won't take. So which is related to, I think you talked about the SCADA system integration. So, so today there's a lot of real-time data which is getting integrated. So how can you share more details in terms of what kind of systems can ArcGIS integrate with for the real-time data?
Okay. So now with ArcGIS currently for real-time data integration, we have a specific module which is called as the Geoevent Server. So this Geoevent Server can integrate with any of the live devices that can give out services if it can provide. And currently the capability of that is to fetch data of about 10,000 records per second. So that is the kind of data that we can capture, and that can be fed into the system on a near real-time basis. So subject to all the network latencies and all those things that we have. But from the data capture wise, yes, it is possible. And it also depends on at what interval we need to capture this data, whether it is per second, per 10 seconds, per 30 seconds, depending upon the criticality of it. So any of the smart devices that can provide information, whether it can be temperature, whether it can be outages, whether it can be AMR meters, we can start capturing information from any of the smart devices that can give out input as an input for us.
Okay, thanks, Pradeep. So I think I've exhausted the list of questions that are there. So probably we still have time, so we can wait for a few more seconds. If there are any more questions, we can take them up. I think while we are waiting, I just want to share that the video recording and the presentation will be available to all the registered participants after this webinar. So, and if you still have any further questions, which you have later, you can always write to us at info@esriindia.com, info@esriindia.com, and we'll have our team, Dr. Pradeep and Mithika, respond back those questions to you. I think still no questions, so probably we can close the webinar for today. So Shawdeep, back over to you.
Thank you very much.
Sorry, we just got one question. Sorry for that. So this is a question. I probably will take this question and then. How ArcFM can be transferred to the new Esri utility model? Any light on this? And have we done any analysis in this line?
Okay, when we talk about the ArcFM to the new Esri data model, I would say it is work in progress because Esri is working on the new utility data model wherein it is trying to bring in all the utility related intelligence that is there and what it has gathered by working with the Geoevent and Schneider currently from the ArcFM and building it into the core geodatabase. But a full transformation and a full-fledged transformation from an ArcFM to the utility data model would take a little more time because it's more of an incremental work. It's the base data are being done. But as a build-up to that process is that the systems now would be compatible more from the 10.6.1 version coming up, so that there is easy compatibility when we move from the data configured within ArcFM to a data which is configured from within the Esri geodatabase. But for the business layers, yes, still we would try to use the ArcFM defined business processes and rules and intelligence. The data model would definitely move into the Esri utility network model.
Okay. I think that's Pradeep. So I think we have run out of all the questions. So I think we'll close the session for today. So Shawdeep, over to you.
Thank you very much. I would like to thank all the panel members and participants who joined us today. Hope you all have spent a useful time. That does conclude the webinar. Wish you all a great day ahead. Thank you very much.